Okay, let us go back to Sec 3 work. Now, this is on speed time graph, speed time graph, distance time graph, acceleration time graph. Okay, now this is an example of how we can use graphs to represent real world things. Okay, so let us start by just explaining to you what a speed time graph or how to read a speed time graph. Okay, so speed time graph, as the name suggests, right? Now we are plotting speed against time. That means as time passes by, let's say 0, then 1 second, 2 second, 3 second, 4 second. You read it like that, okay? As time passes by, what happened to the speed of the particle or the object or the car or whatever? Okay, so if as time passes by, 1 second, 2 second, 3 second, the speed time graph, if the graph looks like that, right, what does it mean? It means that it has 0 speed. That means it's not moving. See, you start the stopwatch, right? You start 1 second, 2 second, 3 second. It's still at 0. That means it's not moving. After that, right, suddenly from 3 second it goes up like that. Now what does that mean? It means that in 1 second it increases its speed by a certain amount, let's say 10 meter per second. Then in another second it goes up by 20. It goes up to 20. So what does this mean? It means that as time passes by, the speed is increasing. Okay? Yeah, so what does this mean? It means that it's not traveling at constant speed, If it's constant speed, you see, okay, let's say I start again. Ready, go. This is called constant speed. That means as time passes by, my speed is like maybe 1 cm per second. This is called constant speed. How do you represent constant speed? Constant speed is represented by a straight line like that. So when I go 6, 7, this is called constant speed. Okay, you need to understand all this. That means as time passes by, what is my speed? Oh, it is 20 all the way. See, 5 seconds is 20, 6 seconds is 20, 7 seconds 20. That means this constant speed means constant is like a fixed number lah. It's a fixed speed of 20. Okay. Whereas down here, 3 to 5 seconds, right, it is accelerating. So this is acceleration. Then later, let's say after 7 seconds, it goes down. Okay, then this is deceleration. That means the speed is getting less and less. Speed getting more and more is acceleration. Speed remains the same is constant speed. And then speed getting less and less, it means it's deceleration. Okay? Now, once you understand this, we can use what we have learned in lower sec, the gradient of lines, okay, to help us find the acceleration. How come can do that? Because gradient is rise over run, right? So if I take speed, this rise is speed. Speed over, this one is time, right? Time. Then I am actually finding the acceleration. So when I find the gradient of a speed time graph, it is actually acceleration. Because acceleration is how fast the speed is changing with respect to time. Okay, now if I were to find this gradient, then you'll be, don't you agree the acceleration is rise, that's 20, right? Over run, that's 2, right? So isn't it 10 meter per second square? Now why meter per second square? Because down here is meter per second. Then this is second. So meter per second divided by second. You learn in kindergarten, it is like that, right? Divide change to times, so it's meter per second square. That's why it's like that. Okay? Now, when you do this part here, Okay, wait. Before that, I show you another way to find the acceleration. Okay, acceleration you can also use you know the gradient formula. This is like x, this is like y, right? So this point is 520. This point is 3, 0, correct? So you can also use this gradient, or gradient is acceleration, or the gradient of the line, okay, is y1, which is 20 minus 0 over 5 minus 3. Isn't it 10 meter per second square also? So there are two ways to find, okay? Now, which way you should use, or which method you should use is all up to you, but you must be very, very careful. Meaning to say, a line that is going up like that, right, should have a positive answer. Now, I'm going to show you how to find this deceleration. Okay. To find this deceleration, right, I can use rise over run. So rise is 20. So 20 divided by 2 is 10 meter per second square again. But in this case, it must be, so if I say deceleration, then it's like that lah. Okay? But if I ask you what's the acceleration here, it will be negative. Okay? Why negative? Because the line is sloping downwards. Okay? Are we clear? Okay, then if I want to use the gradient formula, isn't this point 7, 20, and this point is 9, 0. So using the gradient formula, it will be 20 minus 0 over 7 minus 9, which is 20 over minus 2, which is minus 10 meter per second square. So when you use the gradient formula, you must be very careful. You are actually finding acceleration when you're using the gradient formula. Okay, so when you get a negative gradient, it means that the acceleration is negative, and it means that deceleration is 10 meter per second square. Okay, so for those of you who are easily confused, I would suggest you use rise over run, and then you see what the values are here, and then you do accordingly. Okay, now let's elaborate a little bit more on this. Let's say now the graph looks like that, then like that, then like that. So what does this mean? This means deceleration, this means acceleration, this means constant speed. Correct? How about if it's like that all the way? Then this is constant speed all the way lah. Okay, one last one. What if it's like that, then like that, then like that? So this acceleration, to find this acceleration, you have to draw a right angle triangle here, find the rise over the run. Okay, must remember the rise, right, is this value minus this value, because we only want this length. Okay, and this value minus this value is the run. So if I ask you to find deceleration, right, you can use this rise over this run, and be very careful. This rise is this minus 0, but this run, if let's say down here is 100, right, and then this 80, it's not 100 for the run, it's 100 minus 80, so it's 20 here. Okay, so be very careful. And if I ask you for the acceleration here, it will be a negative value. But if I ask you what's the deceleration, then the deceleration is just the rise over the run. It's a positive value. Okay, now we will go now to a question. Okay, I haven't spoken about distance time graph. I'm going to use this example to do distance time graph. Now a particle accelerates at 4 meter per second square. So the acceleration is 4 meter per second square lah. Oh. So where's the acceleration? Has to be here, right? Accelerate, constant speed, decelerate. Okay? Accelerate, constant speed, decelerate. And reaches a constant speed. They already told you. So this is a constant speed lah. This is the constant speed of 30 meter per second in 5 seconds. Okay? After that, it went on a constant speed, then later decelerate. Okay, so what did they ask you to do? They ask you to find the initial. Remember, initial, this word means when t equals 0, when you first start timing. Okay, so they want you to find this speed lah. That's all. Okay. How do you do that? Yeah, how to do that? They tell us that acceleration is 4. We know, ladies and gentlemen, that acceleration is when the speed is increasing like that, right? This acceleration, this deceleration, right? Accelerate, constant speed, decelerate. So to find the acceleration, which actually is given, where is it? Here. Don't you think it is just this rise over the run? Correct? So I don't care. That they already give me this. I just know that my acceleration is 4, and to find acceleration is the same as rise over the run, which is 4. So this is 4, which means that my rise, okay, I can call it x lah, sorry, I can call it anything I want. I call it, let's say, m, okay? I don't know m, p. I call this length p, easier lah, easier. So don't you agree that p is 4 times 4, which is 16? Okay, so this is 16. So is this 16? No, ladies and gentlemen, no. It means that from here to here is 16. So you must take 30 minus 16, which is 14. So this is 14. Correct or not? If this is 14, 30 minus 14, then this will be 16 mah, which is your rise, right? Okay. So the answer is initial velocity. You can call it v lah. Okay lah. Never mind. We call it v lah. You can call it anything you want. It doesn't matter as long as you can do the question. Okay, you know. Okay. So this initial velocity is initial speed is 16 meter per second. Okay, that's all. So it actually, the story is like that. It started off when you first start, then you ask, how come when you first start timing it has speed? Yeah, because this object you see, like now I'm talking. I'm talking. This thing is actually moving. Then now I take my stopwatch, right? Then I say, okay, ready. I will start timing now. Go. But when I press, it was already moving. You see, as I was talking just now, it was moving. Then I pressed it when it was somewhere here, right? So it actually was moving with a certain speed initially. I pressed the stopwatch here, right? So it can be like that one, okay? It can be like that. Then it go up, increase the speed, then it remain at the constant speed. Then later, don't know what happened, it slowed down, but it didn't go to 0, it stayed here. Okay? Then they ask you now to find the deceleration. Okay, deceleration. You know this acceleration, constant speed, deceleration must be here. Draw a triangle, right angle triangle. Then this is your rise. Okay, you can call it whatever lah. Okay, now we call it P. Overrun. The run, isn't it 24 minus this is 6, right? Oh, that means okay, we want to find deceleration. Deceleration is they didn't tell us. They didn't tell us. Okay, so we know it's rise over run, right? And the rise is what is it? Oh, no need P lah, you see? 30 minus 5 30 minus 5 is this length this length here. So 30 minus 5 is 25. So 25 divided by 6. 6, 12, 18, 24, 416 meter per second square. That's it. Okay, must you put a minus here? No need, unless they ask you for acceleration, then this is a minus. Okay, are we clear? So I hope we are clear about this. Now, the next question they want us to do is to draw the distance time graph. So as I mentioned to you, right, I need to tell you how to obtain the distance time graph from the speed time graph. Okay, so very simple. Okay, you have to follow these timings given to you, meaning to say that this is one block, this is another block, and this is the last stage, or you can call it one stage 2, stage 3. Why is it divided like that? Because down here, right, wait, because down here the object or the particle or whatever the thing is, right, down here to here is accelerating. So when it's accelerating, right, it is like moving in a certain way, so we will calculate that way. Okay, then later constant speed, here to here we will calculate the constant speed, how much distance it traveled. And lastly, when it's decelerating, it's moving in a certain fixed way, we will calculate that certain fixed way. Okay, so let me just show you how to do. We are now trying to find the distance, or draw the distance time graph. Now, you remember your primary school, you learn distance, DST, right? So don't you agree to find distance? Okay, to find distance, you take speed times time. Isn't speed times time the area of this thing? Because speed, okay, times time, that's the area, speed times time, you're finding the area. Alright, so remember, area under a speed time graph is the distance traveled. Okay, then how do we do it? Very simple. You use this thing called area of a trapezium. Trapezium always has two parallel sides. Okay, it's something like a triangle. Half, they take half, right? Then the distance between the two parallel sides is 5, right? Half times, it's something like the base. Half times base. Okay, then times the two height add together, the two parallel sides, right, add together. So it's 14 plus 30. That will give you the distance traveled for this part here. So let me just calculate. 0.5, you go and calculate also, okay? Times 5, then 44. 110. That means in the first 5 seconds, ladies and gentlemen, in the first 5 seconds, it traveled 110 meters. Oh, sorry, it's not meter per second, but it's meters. Meters. Okay, now how do we represent this distance traveled? So you see, you look at the time, look at the speed. If your father is driving you in a car, and then the car going faster and faster and faster and faster and faster, the distance cannot be a straight line. Straight line is constant. So it must be going faster and faster and faster and faster and faster, right? Like that. Okay, stop here. In 5 seconds, I travel 110. Alright, now the next block is very simple because it is just a rectangle. This part here is 18 minus this, right? So it's 13. This is 30, right? So it's just 30 times 13. That will give me 390, right? 390. Okay, so do I label 390 here? No, ladies and gentlemen, you label 390 here. Wrong. Why? 390, if you label 390 here, right, you're saying here to here is 390 leh. But know what? It is here to here. This part alone, this part alone, you see, This part alone is 390. So it should be 110 plus 390, which is 500. Okay. And you see, because you are traveling at constant speed, right? Constant speed. We mentioned in class what constant speed means. You must use a ruler. Very important. You don't use a ruler in the examination, 0. Okay? Must use a ruler. Don't use freehand. Even those very nice freehand cannot. You need to use a ruler. And don't draw so many lines like me. I'm just trying to okay, don't draw so many lines like me, okay? Then down here, right, the transition must be a smooth transition, okay? Then after that, how? Decelerate, getting slower and slower and slower, right? Remember? Faster and faster and faster, constant speed, slower and slower and slower. Remember this? Pale. This one is faster and faster, faster and faster. Accelerate, constant speed. Okay? Getting slower and slower and slower. Decelerate. Slower and slower. Okay? So you draw this shape, got marks one, got marks one. If you don't know how to calculate all this, you draw this shape, right? Got marks one, okay. Then now, ladies and gentlemen, this is 18, right? So I write here 18, This is how many? This is 24. So I write here 24. Ladies and gentlemen, what is the distance traveled in this block? So again, you see it's a trapezium, and this is 5. This is 30. This is 6. Okay, so it's half times the distance between the two parallel lines. That is 6. It's like something like base like that. Then times the height. But got two height, you add the two heights together. 30 plus 6. Then you use your calculator, right? $108. So do I label 108 here? No, you see, it doesn't make sense. How can this be 108 and this number, what you call that? 110 down here cannot be. The 108 is here. Must remember here. 108. So you plus 108. So this is 608. So that's your answer here. Okay? Now that's how you draw a distance time graph from a speed time graph. Alright? So let me just revise with you what you have learned or revised. The area under a graph, speed time graph, is the distance traveled. And this second part here, right, is this part here, not this whole thing. You cannot label 390 here. Okay, you must add for this part. Then this one, 108, right? 108 is not label 108 here. No, doesn't make sense, right? So it must be 108 is here for this block that you traveled. Okay, and we also learned that, let's say, to find acceleration, let's say this is 10, this is 20. What's the acceleration? It is just the rise over the run. So the acceleration here is 20 over 10, which is 2 meter per second square. And what's the constant speed here? 20 meter per second. And what is the deceleration here? Oh, we don't know. Let's say I draw a right angle triangle. Okay, let's say I know that this is 15 and then this is 20, so this must be 5, right? So the run is 5. If they tell me the deceleration, if they tell me deceleration is, let's say 2, then I know already. Oh, deceleration is rise over run is 2, right? So my rise is 10. So the 10 is here, meaning that you can use this minus 10 here. This is 10. This 10. So this is 10. So you must minus, then you can get this speed here. They can ask you to find the speed here, or they can ask you to find the deceleration here. It's all up to them, okay? Or they can ask you to find the distance traveled. So distance traveled, remember, this is a trapezium, this is a rectangle, this is a triangle. Yeah, okay? So I hope that is clear. I think many of you are very confused about this topic. Okay, then constant speed is like that. Meaning when you see a straight horizontal line, right, is meaning when you see a straight horizontal line, it is like that. Getting faster and faster and faster, accelerate is like that. Decelerate is like that. Okay, so that's all. Thank you.